So we're here to solve this Nurikabe pairs puzzle that I wrote. Unlike a standard Nurikabe, each island will actually have two numbers in it, but we can already see at the start there are some cells, like if this cell were part of an island, it's actually joining three numbers that would break the rules. There are also cells like these ones that are too small to join together, and so we at least know those are not part of the same group. And one thing that will be key as we actually work through this grid is to think about some of these as different groups. So I'll just start with some of them as different colors. And we can start by saying, where does this group, this one in blue, connect with? And it can't connect over to this 3, that's too far away. That takes as many as 5 cells. It can't connect to this, which are 6 away. It can't come over here and connect over to this 8, which would be pinning an ocean cell here. So this group from this one must come somewhere down here and connect to one of these numbers. And I think right now in the grid, it looks like it may be able to connect to this 8 clue. It may be able to connect to this 11 clue, but we get a situation where this 3 is a different color. It's going to have to come up and actually connects to that 2, so we get some connection with those spaces. This one up here can't come over to the left and connect with anything in this space, so it's going to have to come to the right. And notice it can't dodge around without joining to this 8. So this one and this 8 are part of the same group for sure. Let's come to a different clue like this one. And this one is as constrained as the blue partner it had in the upper left. This one can't join to this 2, can't join to this 2. It really doesn't have a credible path to get all the way up here. That's too far along to make to that 8. And so it's going to have to come somehow over to the left of the grid. And doing this, you'll see it's going to be forced to join based on this being now a forced ocean cell. It's going to be forced to join to this 8. And so this 8 and this 1 are two groups you can quickly force in the grid as joining. And then that means this blue one over here has to keep coming down. And it's taken 7 cells, so connecting over to this 8 would take 10. That's too much. 1 plus 8 is 9. So this 11 is what's part of the blue group. That means that these two islands must come together, and while there are 5 total cells, I'll always take these 4 in the middle. This green down here can't come over to join to this 2, that's too far along, so I'll always join to this 8. We'll put another color, and let's use orange. This 3 has to come out, and in coming out, we'll see it can't join to this 2 or to that 2, so it always joins to this 8. And these 2's come together and form that shape. So we've got the pairing of digits as an early step in this puzzle, hopefully not too hard, but something that gives you a great start to think through how to approach the logic in this variation. For these orange cells to come together, we'll always take this cell. I'm not sure there's more we can do right now with that. For these blue islands to always come together, they always take this cell. So there are a few tensions in the grid right now, and the tensions are mainly around spaces. Let's do something like this. Spaces where we have essentially groups that will need to get some island from them somewhere. And notice that this brown group here has taken 4 of its 5 cells, so in the best case it can take one of these above, but it's not going to be able to reach into this 2x2 box that's marked like this. And this blue group right now has taken 7, 8, 9, 10, 11 potentially, so it's got one more to take. So it can reach into essentially one of these 2 cells, but it can't reach over to this space. And so we still have to get some island into these cells, and the only way that can come in is from this island group at the top. And so marking some of this in, we'll see that we actually now have 5, 6, 7, 8 potential cells used through this island already. And so it's actually the case at the start of this puzzle, after we mark these pairs, that this cell can't be reached by any island, this cell can't be reached by any island, this cell can't be reached by any island. And that forces this 2x2 group to come in. And it actually forces this efficient packing of the island at the top. And it's going to complete the space that we can put in that 5-cell island here. We should be able to recognize that if the blue group is a connected island like this, and this ocean has to get around it, that the ocean will have to bend through this corner for sure. And we can put in some more cells we know, like this, and this cell can't be part of an island, so it's part of an ocean, and that completes the brown group, which puts these cells in and makes this a force blue. A thing to then note is about the these two green cells, and so a question you can ask is, do the green cells reach to this bottom row? There's a place where the ocean itself could come across the bottom row and stay connected, but because there are only 5 or 6 cells that are part of this island, however this goes, it takes at least one of the cells in the bottom row, and so a way to kind of visualize this is there's some break of connectivity formed by this island that will touch this row, and so the ocean for sure comes from this bottom space, works itself up this channel through cells like these, and working up this channel, it gets connected. Similarly, these two ocean cells have to be connected, and so they have to work through this group to get connected. So let's keep coming out. This ocean is still somewhat stranded unless it uses a cell, and now we have this island group, which is taking everything through here, unless again we wrap around the corner of the grid, which we do. And in wrapping around that corner, we see that we can form exactly an 11-cell island group. We have these cells that have to come in and over. We've got 5, 6, 7. We're going to have to take 2 more from this. We can't reach all the way down to here, or we'd isolate that ocean. We can't reach all the way over to here, or we'd isolate that ocean. So we're going to have to take basically 1 cell more over, or 1 more cell down. But notice that in no case do we reach these extreme edges of the border. So this will always be part of an ocean that now is actually forced from the pink. This will still always be part of an ocean. We have to take one of these cells here in pink, which means that the ocean is going to have to come around them somewhat. In doing so, we now actually see that we can't have an island reach that corner cell, so it puts in this last ocean. We're going to have now a space where we've got to fill in this group of 9, and if we do count, we'll see that this group of blue is forced exactly like so to get to 12, and so there's exactly 1 packing left, which is right here. So this Nurikabe pairs puzzle really helped by thinking about how to connect the islands, but then after connecting those islands, seeing the particularly stranded upper left corner that has to have some islands reach into it. And if you got all those logical steps sort of packed out in your mind or use colors like in the PenPy edit interface, this is a pretty easy puzzle to then work through, getting all the way through the end by seeing how we have to avoid the edges of the grid and let the ocean mostly use the edges. So hope you got something that applied for this puzzle, but many of these approaches will apply even for standard Nurikabe as you think about connectivity and edges that must be ocean in some situations. So we'll see you again soon.